Hi everybody, welcome to My Physical World. Today we're going to open up our ArcGIS. In my case I got 10.7 going. You might have ArcPro or something like that. We are going to look at working with LiDAR data. I use LiDAR data when I'm doing a lot of my geospatial analysis. And currently right now I'm doing some research on the history of glaciation in our local area. My local area happens to be Huron County, Ohio. And I'm giving tours and showing people via video or whatever glacial deposits in our county. And I use LiDAR data extensively. What is LiDAR data? LiDAR stands for light detection and ranging. An aircraft flies over the surface of the earth and has laser data, laser equipment installed on the aircraft, and it scans the ground, and those returns return the elevations of the ground and trees and buildings, whatever's on the ground. Okay, so what I'm going to do is we're going to load in a little bit of LiDAR data, show you how you can work with it in ArcGIS. We're going to create a LAS dataset. A LAS, L-A-S, is actually short for a LiDAR exchange file. It's kind of like you people that are in the AutoCAD world. It's kind of like a DXF. Okay, it's an interchangeable exchange file. Okay, so what we're going to do is I've downloaded some LiDAR data from the Ohio Geographic Resource Center because a lot of our state has had LiDAR flights, and we're lucky to have in our county, since we're close to Lake Erie, where they do a lot of lakeshore studies, that our county is close enough to Lake Erie that we qualified for the first run of these LiDAR data sets. So we're going to add data, and I'm going to show you. It should take this right to my directory, my LiDAR directory, and you're going to notice a whole bunch of these files that have these numbers with an extension of LAS. LAS is the exchange file naming format. The N stands for north, okay, the northern part. The numbers mean something, okay, and we're going to go to, I know my particular area that I want to show you as our example is 1930, 525, all right. The 1930 is an abbreviation of 1,930,000 feet, and that's an easting. Okay, so they have an arbitrary point in the state that is 0, and this is based on the state plane coordinate system. So it's 1.930 million feet or whatever away from that arbitrary point to the east. The 525 is the northing in state plane coordinates, and this is short for 525,000 feet. All right, so we're going to click on this one. Oops, I clicked on it already. I don't want to rename it. And we're going to add this, and then I'm going to just ignore the next one, hit OK. And we get this LiDAR data set. And what it is if I zoom in, you're going to notice that LiDAR is just a bunch of points. And these are returns from the laser equipment to the aircraft. And it records the elevation above mean sea level. Okay? So let's zoom out to the full extent again. So it's a series of points. That's all a LiDAR is. Now, ArcGIS has a toolbox called LAS Dataset. Okay, you can right-click in the menu area and just make sure that LAS Dataset is checked to bring that toolbox up. Yeah, Oops, happy fingers there. All right, so here we have the last data set, and this is not a last data set. We have a last file, and we have a series of points. Now, you can kind of easily see or subtly see the differences in elevations just based on the color that ArcGIS automatically applies to each elevation of each point. Okay, so right now we're looking at a land feature that's called a esker. It's a glacial feature. It was an ancient channel underneath the ice that filled in with consolidated sediments and rocks and things like that. And when the ice melted, it creates this long ridge-like feature. Now, using the last dataset toolbar, we can go into the 3D view, and we can look at this LiDAR data in 3D, and we can spin it around. We can zoom in and out, but they're point data, and it's not all that, it's not, the points aren't close to each other to really make out the feature, but you can kind of get an idea of what that feature looks like, okay? Now, if you notice, we got this blue and we got this light blue, and we get into some yellows and some oranges and some reds. Now, the reds are actually the first returns. The laser comes down from the aircraft, hits a feature, bounces back to the aircraft and gets an elevation reading. The first returns are in red, and these first returns happen to be trees. Okay, now I'm going to get out of here. We're going to come back over to this last data set toolbar, go to filters, and we're only going to turn on the ground. And you're going to see all that red, all the red disappears. And then we'll go back into 3D view. And now you see the ground without all the trees. See, that's the cool thing about LiDAR. Now, this is a government program, so the spatial resolution isn't as great as what you would get with a commercial product. You can hire commercial companies to do your LiDAR flights, and your point spacing is going to be much closer together. But this is provided by the state of Ohio, which is pretty darn cool. And it's useful for doing all types of stuff. But in this view, you can check out, you can see this is what the ground looks like. We turned off all those trees, all right? Another thing you can do in the LiDAR dataset toolbar is you can visualize your data in different fashions. So I'm going to leave it just on ground. I just want the ground echoes. I don't want the trees in this particular case. And I'm going to come over to the raster setting, and I'm going to set it to elevation, and it's going to create a digital elevation model. Okay. Basically, it's actually a TIN. It's a triangular irregular network is what it is. If I zoom in, you're going to see a whole bunch of triangles. Okay. I'm zooming in my data, and so I got a whole bunch of polygons, and it creates this grid network based on the same data off of those points. Now, if I go into the 3D view, now you have a better view of the ground, and in this particular case, you can make out this glacial feature called an esker really, really well. Oops, what did I do there? Yeah, I zoomed in way. Okay. So you can see your geologic structure really well when you turn it into a TIN. Another tool that you can use is you can use aspect, which shows you the direction that each polygon faces. If you look over here, you're seeing north, northeast, east, southeast, etc. And that tells you that that polygon face is pointing in a certain direction. For instance, all the red faces to the north, whereas all of the cyan, the light blue, is facing to the south. This could be really, really important when you're doing vegetation studies. Okay. Also, you can do it if you're doing architectural studies to find out, sun exposure and things like that. But that's aspect. Another setting that you have in the grid is slope, and the colors that you see in the slope obviously is the amount of pitch or slope of the ground. All right, so if we notice that here in this esker feature that we have, you see some orange and you see some yellows, and then it has greens. The oranges and the yellows, they have a steeper angle to them. Like this orange right here goes up to 56 degrees, whereas the darker the greens are, the flatter the ground is. So you can use your LiDAR information using this toolbar to look at the slope. And you can also go in and you can generate contours with your LiDAR data. So here you can go in and you can specify a contour index, and you can change these contours to match whatever contour interval that you're interested in. Okay, so we're going to go back to elevation. Another thing that you get with the last dataset toolbar is that you can do profiles of your geography. All right, so if we wanted to see the profile of this esker coming off here, I can hit the profile tool, and then I'm going to click here, and then I'm going to click here, which establishes that section line that you're going to do the profile. Then you kind of drag it out a little bit to get a swath of data points, and you click and you get a profile. So as you move your cursor along that profile, you'll notice that up here that this red line is following where my cursor is. So if I want to be up on top of the hill, you can see that red line is up on the top of the hill, and then we come down to the flat area and that red line follows along. Now the thing about working with these two views, the profile and the 3D view, if you wanted to make a map using these profiles, you basically do a screen print and you bring it into some graphic software such as Corel Paint or GIMP, and you just create a mask around it and create a new image based off of this, and then add it to your map. Okay, some of you might know some other ways to do that, but that's usually the way I do it. All right, so now one other thing that you can do is, if I bring in, for example, this is 1930 525 is that panel. If I want to bring the one that's up above it, which is it's the same column, but it's a different row. So I want the 1930, and I want the panel that's up above it, which would be 530. Remember, 530 is the northing, and the 1930 is the easting. So I'm going to bring in 530, which is the panel right above this one. So I'm going to add that, and then I'm going to OK this one. And notice that now I have both of these panels in view. All right. Now, when I brought in the other one, it goes back to the default of being just the LiDAR points. And I'm going to convert those to the tin again. And I'm going to come up here to my last data set, and I'm going to choose the one that I want to convert, which is the 530. And I'm going to turn just the ground on, and then I'm going to convert that into my tin, or my kind of like my DEM. But I want you to notice something. These two are side by side. One's just north of the other, but the software is going to interpolate them totally separate, okay, based on the highest and lowest points in that particular data set. So if you notice that this esker comes up in the bottom view, in the 525 view, this esker is kind of like a light blue right here. But when we reach the same elevation crossing the line into this data set, it changes it to orange. That's because the range of elevations in this LAS is different than the range of elevations in this LAS file. Okay, so it treats them separate. Well, how do you get those to, how do you combine these two in order to get a good graphical representation of the elevations for both of these together? All right, well, that's where we come over here to catalog, and I'm going to create a short one here if I can. I'm going to come over here to my Huron County LiDAR directory, and I'm going to right click that, and I'm going to select new, and I'm going to come down to LAS Dataset. And what that does is creates a blank data set, LAS dataset down here, and I'm going to give it a name, maybe. Okay, I'm going to type in Huron County test. All right, now I'm going to hit enter. All right, so it creates this new data set. Right now it's empty, called hctest.lasd, which stands for LAS dataset. Now I want to double click that, and now we're going to add in the data sets or the LAS files that we want to combine. The first thing you want to do is you want to select your coordinate system, and I'm going to do state plane, nat 83, cores 96 US feet. And I'm going to come down here to Ohio North, because that's where I am. And that's going to be my map projection for these two LAS files to be combined. Then I'm going to go over to Files, and I'm going to add in the LAS files that I want to combine. All right, so sorry, but I got to get over here and go down to my GIS data. And I'm going to come down here to my LiDAR, Huron County, and LiDAR again. And I'm going to go through my list until I find 1935, 1930, 525, and 530, because those are the two last files we have in our view right now. I'm going to open those. It's going to add them to our list. Okay? Now, in order for it to calculate the elevations for both of these LAS files combined, I need to go into statistics, and I need to, well, I guess I don't need to. It automatically did it for me. Okay? If the update button was not grayed out, then you would have to update the statistics to combine the two. All right? So I didn't have to do that. But let me see. Yeah, each one's good. So hitting this little 3-dot button in the statistics column for the files does the same thing as going to statistics and doing the update, but this one does all of them at once. So I'm checking my individual files to see if I need to update my data and my statistics for the LAS files, and I do not. So that's kind of good. All right, so we have the LAS files selected. We have the statistics. There's no need to update them to combine the values. I got my coordinate system set up. We won't talk about the Z coordinate system right now. And then I hit OK. And basically it goes in and it combines the two last data sets, last files, into one continuous data set. Okay. And what I can do is, okay, it should update it now. I'm going to turn these two off. And I'm going to go to my catalog. And I'm going to grab HC test. And I'm going to drop that right into my project. And I'm going to zoom out. And notice, okay, I've turned the two individual ones off. And the last data set that combined the two is all in one, basically one virtual file. The data set is just a pointer to these two files. It doesn't actually physically combine them, but it puts them together and calculates the statistics for both last files to basically combine them into one. Now you notice that these elevations where they meet, they're continuous through the two panels. So now we can see this esker continues up. Now let's come over here to our last toolbar and choose our SC test, because that's the one that we want to manipulate, and turn it to ground, and all the trees disappear. And then I'm going to come up and we're going to change that to, we're going to create the 10. And now where these two combine, remember here's where the elevations changed right here and the colors were different. Now it's combined into one. Now we get a good view of that geologic feature, which is an esker, and we can see that it actually kind of comes all the way down and all the way up. And then there's some erosion areas of the esker over the thousands of years that they were eroded by wind and water and things like that, these gaps. But yeah, that's working with LiDAR data, and we're going to continue this video further and do some more stuff. So we'll see you in the next video. See you later.